Welcome back to the stream, folks. This is my attempt at continuing where we left off after a boatload of technical problems. So fingers crossed, things should be working better this time, but please let me know if you happen to be watching this live and notice anything unusual. Yeah, there were a whole host of technical problems that I think some of them were just things that had been a little flaky for a while that just happened to be more flaky than usual, like some video flickering in and out on one of the monitors here. And then some of the problems were sort of cascading effects of doing a Windows update, which then reset a bunch of the settings on one of my video capture devices, which then kind of broke some things in this way that I didn't really understand how to debug, and in trying to debug that, I upgraded the firmware on the video capture device, which actually caused this other bug to show up. So then I ended up resolving it by downgrading the firmware on the video grabber. So that and some other random offerings to the EMI ether around here seems to have fixed it. Tico's having a chill day today. Personally, the top of the rack is a little bit warm for me, but it seems to be the kind of climate he enjoys. So this is continuing a small series that I've been doing recently on, well, a series of streams that will culminate in, currently I'm aiming for this to end up in one edited video, plus hopefully some more open knowledge about how these eye trackers work so that we can maybe do additional open source work on getting them working in strange environments. So the deal so far is that I've taken apart two eye trackers made by this company, Tobii, who makes a range of eye trackers, including some eye trackers that are actually aimed for assistive technology purposes, which is that's the kind of main reason I'm investigating this, to see if it's possible to create, well, to enable additional assistive technology, devices basically, to be created by people who have the skills to do that for a lot less money than traditional assistive technology. Right now that stuff is really expensive, and it's really designed for people who are either rich or have good insurance. And if you are neither of those things, then you're stuck either spending a lot more money than you can really afford on something that you all of a sudden need because of an illness or an accident, or maybe your kid needs it because they've gotten to an age where they need a certain type of input device and the insurance won't cover it. So, those are the kinds of circumstances where I think maybe there's a gap in what's currently available, and that, AT Makers, who's, Bill kind of pointed me toward this project. AT Makers is really about trying to take all of that extra skill and enthusiasm in the DIY and maker community and trying to connect the people who want to create something with their skills with people who really need a bit of technology that's tailored just for them for an affordable price. So, and that's the kind of overall framework, is that we're looking at finding a way to connect those people that aren't currently connected, to provide new opportunities for new assistive technology for people who don't currently have an option within the current economic framework. And so within that, the goal here was to try to open up some of this eye tracking technology so that people who are already looking to build something DIY to help someone with a specific need, the goal here is to open up some of this technology so that people who have the skills can adapt them for specific people's needs using inexpensive parts. So far I've looked at the iX controller, which is designed for gaming. Let's get some of these on the DSLR view is actually what I was having most of the problems with. This is what I had to downgrade the firmware on the grabber to support. something about the interlaced mode that it uses. All right. So this one in the back is the Tobii iX controller. This is the one we looked at first, and this is This is the one we looked at first. This makes an interesting reference point because this is kind of an implementation of their design where all of the processing seems to be done on a PC, specifically a PC with some spare processing power. And this device is actually a very specially tailored USB 3 webcam. So it has a camera with an IR filter in front of it. It has these 3 infrared illuminators, which presumably are going to be modulated or sequenced in some way. It's got a USB 3 microcontroller with its corresponding firmware in an SPI flash. And then this looks like a plain old USB Mini B, but this is actually a USB 3 in kind of a strange dual layer USB 3 mini connector. It's pretty weird. So anyway, this was a pretty interesting reference. We looked briefly at the software and enough to kind of see where the different pieces are implemented. It has a lot of C# code implementing the higher layers of kind of interacting with the Windows operating system using your eyes, and providing various SDKs for games and for applications written using Unity to interact with the eye tracker. So then there's a whole bunch of other lower levels, including what looks like just some plain kind of C++ DLLs that actually provide the actual tracking, and separate DLLs and actually separate processes, it seems, that do the tracking and the image capture. And then the interface between the image capture and the interface between that image capture daemon and the hardware is actually not USB video like you might expect, but it seems to be a vendor-specific bulk-only protocol that they can access from user space easily. So that was interesting, but it seemed like a good, it seemed like the iX might not be the best thing to attach to something like a Raspberry Pi, because you need just a huge amount of processing power on the embedded system to implement those algorithms in software and just to move around all the data. Part of, I think, what the new model, this Tobii 4C, which is more expensive but is still pretty affordable. I think this one is something like 150 rather than closer to 100. So, so I think the iX was actually less than 100. I think that was like $80, but I should just avoid, talking out of my butt. I should actually pull up the product pages if I'm going to talk prices. Anyway, the 4C is more expensive, but it uses a USB 2 rather than a USB 3 connection. It's still pretty affordable. It's still kind of an expensive computer peripheral rather than like an entire laptop's worth of investment. And it has a pretty interesting design. It actually has 2 cameras. So we're gonna actually end up needing to go back over this under the microscope, since I actually ended up losing the microscope footage from the last stream, and then I tried to reshoot it later that evening, and then the footage I reshot was unusable because it ended up in standard def for some reason. So, well, I know exactly why. It was another software upgrade. I upgraded the drivers for that video recorder, and it reset the settings, and so it reset the modes that it advertised. Anyway. So yeah, a bit of a recap. Some of that might end up being useful, depending on how much of the previous audio ended up being good. So let's take a look at this under the microscope. And then the plan is to just plug this in and watch it interact with the Windows software while we have the USB traffic under the analyzer. So I've got a hardware analyzer here, a Beagle 480. So the plan is to use this to snoop on the communications between the Windows software and the EyeChip, which is their ASIC handling pretty much everything in this device, which also just talks directly to the USB. All right, let's put the packaging aside. This is the back cover. This is the still kind of wobbly front lens that I had to remove with a heat gun. This one actually has a pretty nice rigid plastic front cover that I guess acts as both a light baffle and a mount for the lens. It's pretty nice. Oh, good question from DevFlame, who says, I've been busy the past couple weeks. Is the gimbal done? Also, hi. Yeah, basically. There's a little bit of tuning left to do. It's got a little bit of wobble in the yaw axis, which could be that it needs its gains tuned since it's running with a kind of a different weight distribution than it was designed to, but I bet it just needs some adjustment for the parameters that we had to recalibrate. Because I didn't like do a super good job at like making sure those parameters were really dialed in. So I think I'm just going to revisit the calibration, and with another pass at the calibration, I bet the gimbal will be great. I've got a pretty good idea of how to control it over the serial protocol at this point, so at this point I'm just deciding what else goes on the Flyer robot, and then I'm going to build it. So yeah, the gimbal's basically done. If you want to see the progress in code form, there's the scanlime/fy gimbal repository on GitHub, and that has Python scripts for talking to the gimbal and a little bit of reverse engineered documentation. Where did I put the... There we go. I'm still getting muscle memory from my new buttons over here, but they're much more reliable than my old buttons. Oh, and since this is recording that I'm aiming for, I should actually make sure to do the recording. As the battery cover falls off of my mouse. So, start recording the microscope. Make sure the microscope is in the right video mode. 1080 i60 is what I'm expecting. All right. That should be better. Recording. There we go. Turning on the recorder, I guess, caused some of the other channels to drop and then come back on the HDMI splitter. Alright, I've got audio. I've got to make sure the recordings have audio, even though I don't really need it, because I need to have a way to synchronize them later. I can mostly get by with the Final Cut Pro automatic synchronization by audio, but I usually have to tweak it, and just lining up the audio waveforms is usually a pretty easy way to start. Oh, nice. Yeah, gimbal plus eye tracker. That would be pretty amazing, actually. Yeah, actually, that would be a really fun project. You just like look at the image, and it would like kind of, once you get maybe toward the edge of the screen, it could just automatically scroll by tilting the camera, maybe. That would be fun. And actually a pretty nice way to do telepresence, maybe. Oh man, this is so much nicer with the camera actually in the right video mode. Alright, so, well, this is the star of the show so far. As far as I can tell, everything happens in here. They just made an ASIC BGA, naturally. This board is actually pretty high-tech. It, I think, is 6 layers. I don't know if we can quite count them. But it seems to be via in-pad construction. So both of these Tobii controllers actually seem to be using via in-pad construction. So you'll see a lot of normal vias, but then you'll also see these places where, like, obviously there's a via right there, but you don't see a via. The via is just completely invisible, like they filled it in with something, and I think that's exactly what they've done. That threw me for a bit of a loop over here. Like, you'll see this part where I was trying to trace where the power gets through, and this must be ground stitching, but you can just barely see the vias. You might if you look really closely, see these little circular indentations. Let me get something sharp that I can point with. So you might see a little circle there, a little circle there. So those are the vias, but they've been completely filled, and you can just barely tell they're there. So a lot of these passive components, for example, they're going to have the via just under one of the paths, just because they can. So anyway, let's go back and take a tour of this board. I know I did this before, but I've got to get this footage again anyway. So the board is actually really nice. It's, as you can see, it looks like they just cut out a piece of probably, I think this is aluminum. Do I have a magnet handy? Yeah, aluminum. So it's just a piece of aluminum cut to shape as a heat sink, presumably. And then you can also see a little bit of a thermal pad in between the board and the backing heatsink. And cutouts around the mounting posts. You can see the back of the thermal pad. It's like some kind of woven material with an adhesive on either side, I think. Or maybe it's just like a corrugated sheet. Anyway. And then, pretty nice board. And you can also see these lens assemblies have a pretty nice 3D structure to them. Mounted with little dots of glue on these posts. And then that bottom section is actually hollow. And so that little dome on the LED, let me get a pointer. So there's a hollow area right there that the LED fits into. And then the LED hits this shape that to the LED appears convex. But then I think that acts as a, well, I don't know what kind of lens that is off the top of my head. I'm not practiced in optics right now. So someone else would probably have to tell us what exactly this is doing, but we can at least try looking through the front of the lens and we can kind of get an idea of what, like clearly right here it doesn't seem very focused, but I would expect this would be kind of angling and probably dispersing the light over a wide angle. So you can imagine that the light that hits, like the light that goes pretty much straight through this is going to come out pretty much straight. But then pretty quickly, as you start increasing the angle, the light's going to start trying to bounce off of that curve. And then I think you're going to end up with internal reflection kind of bouncing it like over this way and then out. So maybe that's how it gets the wider angle. Also noteworthy, this one doesn't have any of the red LEDs that we saw on the Tobii iX, which was their gaming peripheral. This one just has the IR LEDs as far as I can tell. Lots of larger diameter via stitching right around them for heat sinking. This matched pair here is our USB data coming through what I assume would be a transient suppression diode module. And then a row of ferrite beads right here. So at the top you have a little ferrite common mode choke for the USB data, and then a few power ferrites for the incoming USB current and for the power going out to drive this LED. I'm guessing that since they're not putting a lot of attention into having these switching LEDs really near the LEDs, that they're not really modulating these at super high frequencies, but I could be wrong. They might just be turning them on and off for the duration of a frame or something like that. So if we go back over here, then we have a collection of power electronics. So this, I assume, is one of the main buck converters. This is something I noticed after streaming that I don't think I pointed this out the first time. This inductor's been potted with some kind of kind of cement-looking compound, presumably to keep it from vibrating or possibly to keep moisture out. But this would be a buck converter. But then these components over here I'm less certain about. I think this must be a MOSFET for switching on and off the LED up here. And then that would make this maybe a MOSFET driver. Not sure about this part. So a lot of just power electronics. You would expect this to include a main buck converter, several linear power supplies, and a few LED drivers. So I think that's what we're mostly matching this up with. Not sure about that little one, 2P8, but based on the capacitors right next door to it, I would assume that that's a linear regulator of some sort. And then this little dude. So we see several of these little shiny chips, which would be presumably flip chip BGA packages with a linear regulator inside. They all have similar but not identical markings, which makes me think they're linear regulators from, which makes me think that they're different voltages from the same family of regulators, maybe. This BRW6QAD thing looks like maybe another MOSFET. That could be for the other LEDs, or could be related to turning on and off this camera. And this, I assume, is a visible light camera. I don't see any kind of filtering. It looks like a pretty standard camera module. Then we've got some flash memory, which I assume would have the firmware for their SoC. It might be really interesting to try looking at the access patterns at this flash memory. Stick some logic analyzer probes on there soon. There's another one of those shiny voltage regulators. This one has a different number, or a different letter code. RTARGLD, it looks like. These really crusty looking parts, I assume, are just weird capacitors, but I haven't seen anything like that before. That is a cat hair, it is not surface mount. And then we just start having the regulators and decoupling and oscillators associated with their main system on chip. This is the centerpiece here. As far as I can tell, the USB is just going directly into here, because there aren't any other chips on here that are obviously microcontrollers. The USB just seems to go to an inner layer and then pops out, presumably right under this chip. But the USB descriptors, when we plugged it in, just came right up as EyeChip, so I think that gives away what they're doing here. I'm not sure what the microcontroller on here would be yet. Oh, that's a nice, so Sodium says, courtesy of Ken and Jarrett from last stream, they look like Carclo? Is that the name? Carclo TIR collimating lenses. Oh, interesting. Collimating optics for LEDs, 10 millimeters. Nice. That's pretty useful. So, some interesting test points. I think a lot of these are going to be power supply related. Some of these over here might be debugging or reset. Look at that test point up here with via in pad. It just looks like a bare gold circle. But if you get it at just the right angle, you can see the indentation from a via in the middle. Two more of the shiny linears. There's a nice little cluster of 6 decoupling capacitors. I didn't notice that before. They're really showing off the via in-pad construction here. That's nice. And then this, I assume, is a switching power supply that is specifically an LED driver. It's connected directly to this LED array. It might just be a boost, since the other LED arrays, or the other LEDs seem to be single chips, whereas this one is I haven't looked at how these are wired, but maybe they're in series. So maybe this is a boost converter for driving a bunch of LEDs in series. Also with the kind of cement potting inside the inductor. That must help them avoid singing inductors, which, I assume the last thing you want in an input device people are going to be using for a long period of time is headache-inducing noises. So this is the main sensor. I think it's just another normal camera, but it looks like this has a few special features. It has this foam baffle to try to keep the infrared light from over here away from this. It has what looks like a wide-angle lens, and then it also looks like there's maybe an infrared filter built into the lens. A lot more via stitching, try to get the heat away from this LED array. And then more ferrites, where these are going to be the drive current for the right LED popping out from an interior layer, presumably from one of these MOSFETs, like maybe that one. But that just pops out and then rides the top layer for a while. We've got a sticker and some PCB markings. And then it just rides that top layer right until it gets all the way over here to the rightmost LED. Get some of that cat hair off the lens. Now I'm just filming a little bit extra just in case, and then I'm going to put this away. Alright, let's take a look at this thing in the USB analyzer and see what we got. Make sure to stop the recording. First thing that I did to lose the footage was I rebooted for Windows updates without remembering to tell OBS to stop recording. The second thing I did was just that resolution problem I mentioned. Alright. So, I'm going to try to mount this a little bit. Where by mount, I think I just mean I'm going to tape this to the monitor. This is not going to be nearly as good as their magnet mounting system. So this probably won't be an accurate review of the tracking accuracy. For that, I have a second one that's fully assembled if we really need to break it open. Close the microscope capture. Microscope having some HDMI problems now. Welcome back. Okay, so first up, this is the Beagle 480 analyzer. This is one of many doodads you can buy for sticking in between a computer and a USB device to look at all the packets going back and forth. This one's kind of expensive, but I've gotten a lot of use out of it over the years. I tend to get into a lot of USB-related projects. So this end is the computer that's actually doing the analysis, which in this case is the same computer but a different USB controller. And this is the kind of upstream port to the USB host that we'll be connecting the device to. And then this is where we can plug in any device we want. So if we start analyzing, just as an example, I plug in a USB flash stick. Or this is actually let's put an SD card in there. So we can see the device descriptors. Then we can see Windows starting to poll it and talk to it as a SCSI device. And then if we actually start to look at the files on there, you should start to see the actual data go through here. There's a point around which it just wants to pull really hard to one side or the other. And you can stop this, and in fact this knew how to decode that as SCSI packets, which was pretty neat. But normally we would just see the kind of USB protocol implications of everything that happened. So we would see what endpoints it's reading from, what endpoints it's sending stuff to. Here, if we open up any of these, then we can actually see the USB packets involved. So this is going to be more like what we'll see. We'll see these outs and ins to various USB endpoints. Alright, so that was a good control experiment. Let's actually try, let's try this. Okay, so we already have the same software installed. It's like one package that does all the Tobii eye trackers, apparently. So that software is installed, and let's just start a capture, and it's just waiting for me to plug something in. And here I'm going to plug in the eye tracker. All right. So we had a bunch of descriptor stuff. And accessing a couple of the endpoints that we're interested in. Looks like endpoint 3, endpoint 5, some more stuff, but the device is pretty idle. Let's maybe get a little bit more traffic just so that we can see what this thing does under normal operation. So if we go to the computer and look all the way down at the taskbar, we can see that it says the eye tracking is not configured. So let's see what we can do with that. Oops. Did that work? Can't quite tell if that worked or not. Didn't we have this problem before with the calibration app just exiting? Was that related to the displays? I forget what that was. Oh, what are we doing here? So the sys tray thing here still says it's not configured. Open. Okay, yeah, we had this problem before, didn't we? Oh, geez, what was the solution? Is there something we could run directly? Yeah, this is the problem we were having before. The configuration app just immediately exits. Oh, what was the solution to that? Yeah, we can try running something else that comes with it. Ah, what if I don't want to search? That's the only thing in the tray there. Okay, I have the audio turned off. Hello, mouse. It doesn't think it's working. Let me try replugging it, maybe. Oh, Sodium suggests maybe it was a reboot fixing kind of problem. We could try that. We could do a reboot. Alright, stop capturing. Start rebooting. Cat stream. Oh yeah, James has to save the video before rebooting. Yeah, I saved it right after I was done, so that would have been sad, wouldn't it? Yeah. I agree with Peter. This has been an awesome chat. I really appreciate the folks who show up to the streams to hang out with me while I make videos. I think I might need to move the camera to the other side because Tuco's super cute from that side. Oh, it doesn't quite fit on this table. Let's make the tripod shorter. Looks like the computer is slightly booted. I'm just laughing at James's comment who says, "My girlfriend approves of your hammock." It's a good hammock, yeah. I got that for camping and festivals and stuff a while ago, but then at my previous weird housing arrangement, there was like a big central room where there was space to hang it up, and it was super handy. And so I was pretty happy to find a similar spot in my new digs here. Windows is still busy kind of booting. It's like, I'm ready, really, but everything is made of hourglasses. Yeah, everything is very, very hourglasses right now. It's got to make sure that Steam is loaded. Which is often useful. Oh, that's a good question from Ronnie. Would the Tuco Flyer be able to get that same shot? Yeah, definitely. Yeah, it would just kind of hover in and, you know, sit next to the rack. I would have to make sure that its obstacle detection is not too sensitive, because I might end up kind of pushing it away by moving it around near my desk, but I think that's doable. And James says, I'm thinking that Tuco will probably not be asleep near the Flyer. Just to clarify, the Flyer is not actually going to be a quadcopter. It's going to kind of hover around on nylon ropes, so it should be pretty quiet. I think Tuco won't have any trouble sleeping next to it. Ronnie says, can there be a cat hammock mounted to the Flyer? Oh, that would be amazing. I think I might need more powerful motors if that were the case, though. And I would have a lot more safety concerns in designing this thing. Okay, so I'm trying to avoid confusing this by only giving it the displays I need. Click here to user profile. Same thing with it flashing black. Rodney says, great, more streams to update to the new requirements. Yeah, maybe I should get it sponsored by like a big servo motor company or something. Although, like, honestly, having bigger motors, I really would be worried about safety, though. It becomes a much more complicated project. Debugging and cat stream, but mostly cat stream. Oh. Interesting. I tried running the intro app, then I got this error, no connection found. Which might be simple. Maybe I just need to... Since I did have this thing plugged in, probably without the drivers in a happy state, maybe I should just reload the drivers. I mean, this is just a WinUSB device, isn't it? I've got to reboot again. Okay. That should do it, though. Like, if I reboot, it should reinstall this. And just to make sure that this works, I'm just going to... I mean, just to have fewer variables, I'm going to try connecting this without the USB analyzer in between. The USB analyzer should be transparent to this, but just in case. The computer didn't get infected with the WannaCry ransomware? No. Yeah, no, thankfully, I don't think I would have any vector for that. I'm not going to click on random email attachments, and I don't have any SMB ports open for drive-bys. I know I just have like Wi-Fi credentials like painted on the walls here, but that's a guest network, so. Oh no. DevLam's apparently been dealing with this at work. We don't need this to be Dell stream. Can we have this be cat stream again? The cat stream also has a Dell logo. Can we fix that? Oh, Tuco, you changed directions. Planning on at some point getting a swag program started. This is definitely going to be one of the items. My scanlime sticker. I use them as like almost asset tags around here so that my tools don't get mixed up with other people's tools, but I promise if I start selling them, I won't just try to claim everyone's tools as mine if they start putting them on stuff too, so I'll have to switch to a different system. Hey Tuke, do I need to move this again? Windows is back to its being made of hourglasses again. It's okay, I've got tea. I think it might be happier now. Uh-oh. That works. So I think the Games and Experiences tab is unlocked now. I haven't actually calibrated it as far as I know. I mean, it might be reusing some of the calibration I did for the other iX device. It's interesting that the LEDs around the center don't have a lens. Like, they're just trying to just blast light everywhere or something. Or maybe a lens just wouldn't have been practical so close to the camera. Alright, what do we got? Calibrate? Same problem. Well, can we get an actual error message out of this thing? Oh, there's a blue dot next to the Tobii software now. It says not configured. Or does the blue dot mean this blue dot? Maybe the blue dot is just talking about this coupon, whatever. New calibration profile? Yeah. That wasn't my video input flickering, that was the app crashing immediately. Can I delete my calibration profile? Yeah, these are just all the different components. Well, let's check the device manager, although that's just a WinUSB driver. Let's try this. Oh, here we go. IS4 large. Oh, let's try device manager and then maybe restarting the service. So EyeChip is just, I think, a WinUSB device here. Yeah. If I were them, I wouldn't have wanted to write a kernel mode driver either. Oh, James suggests moving the cat cam to the top right. Good idea. Yeah. Oh! How did I fix it? Oh, I didn't. I think I just reset the settings so that the first run video ran again. That seems to be crashing at the same point. That's pretty weird. Can I run it on the command line, maybe? Oops. Why? That's better. That doesn't have any console output. That's fine. Does it have a log file? We've been here and that didn't help. Let's try restarting the service. Nice dog. Alright, and do we actually have no more Toby binaries running? I think we're fine. Let's start it again. Can we tell where this crashes? Do I have a wind debug on here? Can I not? Got used to the macOS open dialog. That's a different program, isn't it? That intro. I think configuration is what we want. Oh, I need to run this as super user. Oh, this is probably one of those new Windows 10 debug restrictions that I need to figure out how to get around. Anyway, that's probably not what I need. Did I have log files here somewhere? We were in here before, and a lot of this I would not expect to be super relevant to their new EyeChip. Oh, I think before we had some luck by running the service on the command line. Let's try that. Stop the service. So we have service and light core, which I think are the pieces we need. Okay, so, well, we have to run the service as a service. Let's try running, I think we ran the light core on its own and then had the service connect to this instance. I need to run this as admin. I'm not sure if that's something I caused by running it this way or not. It also might be the installer tried to detect what kind of device I had, and something is set incorrectly as a result, and maybe uninstalling it and reinstalling it now that I'm using a different device is necessary. This looks like it's talking to the device, but not the daemon. No, that was connected because I just disconnected it. Interesting. And the sys tray comes back when I do that, I think. It says connecting. Now it says not configured. I'm going to try uninstalling it and reinstalling it. And let's really make sure this is the right download, because this has so much stuff in it that has IX in the name that I'm wondering if they installed something that was tailored to the hardware that I have. I think I might have cleaned out my download directory since I downloaded the last package. RetroJunk says debugging.net apps with WinDebug is probably not a great idea. What is the proper way to debug a .NET app that you just have a binary for? I figured at least there would be a native code something or other that was triggering an exception that I might be able to catch. So let's follow the instructions this came with. Let's be on the not gaming path, but the regular path, because they might give us different software. So, Tobii eye tracking core software. This is what we want. Are you still loading, or did I not actually get a click through to you? Excuse me. Thanks, Chrome. Maybe this is not Chrome's fault. Why is the hell not opening? That was weird. That was like somebody was hogging the disk. Okay, I have 2 copies of this now. Is this the same thing? Yeah. Wonder what the odds are this is going to work. Alright, it's plugged in, volume is muted, let's go. It just opened that for me. It still has my user data in there. Maybe it's crashing because my profile was from the other device. Can I just delete my profile? I wonder where it stores this. Can I use guest? That's still crashing. And this was reloading right after it stopped. Could this be a communication error? Seems unlikely. Whoa, my monitor just blanked out for a sec there. Thought I fixed that. Is that useful? I'd like to maybe delete this profile that it has for me. It just exits right away. Let's kill the service and then delete everything in this directory, maybe. Maybe not everything. What is this? Tracker.model. That looks corrupted. I didn't think we would get stuck right here. Okay, we're stopping the service. Program data for Tut server and Toby. Delete. And any user data. Bunch of log files. Bunch of spy data. Here's the settings. That's not much, is it? That's really not much. Is there something for Tut server in here then? see anything like that. Alright, maybe we'll start the service again. There was one suggestion that maybe this is a bad USB cable. I guess it's possible. I mean, I could try plugging it more directly into the computer. There's one USB extension, but I don't know. So, service is running, and I'm still about to sneeze. Wow, that whole create a new profile thing just... It crashes and it causes this to refresh, which is interesting. So maybe it is a device... Yeah, we can try plugging it in without the serial extender, or the USB extender. I'm going to maybe first try plugging it into this hub, because that's more convenient. I think I'm finally getting allergic to something around here. I used to have all sorts of pollen allergies and stuff when I lived in Colorado, but then a lot of it went away when I moved to California. I've been here for like almost, 12 years, I guess. So I guess maybe they're starting to come back. Okay, we have a hub. Do you see my device at all? There it is. EyeChip. Oh, is that it? Is it working now? Are we having better luck with the hub instead of the extension cord? I see the IR LEDs flashing. Yeah, I think it's trying to work. Okay, let's change the cabling situation. Good suggestion. It's a cabling problem. Wow, what is... that's like... not the failure mode I would expect for a cabling problem. Like, maybe at least a dialog box saying the device has stopped communicating would be nice. Because that looked like the app had just crashed or something. Okay, well, how am I going to do this? Maybe I'll just swap these and use this cable that's going directly to the board for the analyzer. I don't want the analyzer itself and the eye tracker to be on the same hub because that gets confusing. The analyzer is very chatty and we will see some of the other traffic from the same hub. Little cable. Okay, I'm going to try going through the analyzer, because that's what we actually want. And then... okay, we can see the beagle and the EyeChip. Oh yeah, a good suggestion from James that maybe it's like a current issue, and maybe having this powered hub host the current from the LEDs might work out better. Yeah, I might have to turn off the studio lights or potentially reposition this, but I think we're on our way. Let's get this one set up without really looking at the USB analyzer, and then we'll take a look at it and see what we can see. I'm just taping it down so it doesn't move around so much. Having a stationary camera seems good for tracking performance. Oh, that's where I put the DSLR. Let's try this again. Make this problem a little easier for it. Give it no glasses and no lights. I think I can still read this. Oh, let's also change the device, the calibration of the position relative to the screen, because that also changed. I'm gonna have to imagine where the lines are, or maybe hold this up. Something like that. Calibrate. I think this one works with glasses. I just kind of wanted to try it without first. Now I'm just looking for something that could be interfering with this. It's also kind of far from my face. Hello? Huh. I don't think I was looking where I thought I was, or it thought I was. It seems to work out with the ones that are closer to the sensor, but I think I'm going to try giving it some slightly more realistic geometry. How can I do that? I pull all of that closer to me. Very slightly. It might also be upside down. I wonder if that is a problem. Let's try adjusting the upside downness of this sensor and see if that helps at all. Because that would fit in here. Yeah. think that's right setup now. Let's see if that matters. I wasn't sure if that mattered, actually. I thought it might have automatically detected, since the design seems to be symmetric along that axis. But let's see if that works. Lenses. Maybe we shouldn't all be looking at the dot at the same time. That could be a problem, I agree. Why is it only detecting one eye for most of that? I kind of wanted that screen to stick around, but it goes away. And it gives you this without... Oh, this might be working. Says you. Okay. Do we have calibration? Oh, this menu is following my eyes. Nice. Oh, this is working. I don't know if there's a way to click. Is there options for this? This is surreal. What do we get here? That's where we just were. What about games and experiences? Overview. Okay, we've got sound off. I think I can turn off the DSLR. We get what that looks like. Oh yeah, this is where we were before. Press spacebar or enter. That. So I guess it is assuming I have a button. This doesn't do anything. What else is there in there? I don't think this has anything useful. Like, these don't seem to be ways to get into more stuff. That's just like a splash screen. Oh well. Anyway, this should be plenty to get started with looking at the USB traffic. Oh yeah, Len asks if you can click by blinking. Yeah, I was trying to. I figured it would let you do that, but I mean, maybe I would assume that maybe there would be a trick to using this to interact with a mouse, because I mean, this doesn't seem to be giving you a really stable point. It seems to be just kind of fuzzing it together into a big metaball situation. But I assume there's something else that does. Maybe let's just do a quick Google search. Virtual button? Iris. Interesting, so I guess that's not included. So it's designed for this with Windows. I mean, it looked like the stuff included in here, like it was more for like augmenting the existing mouse control rather than just taking over the mouse. So like touchpad dragging. What does this work like? Okay, so I have to move it, I have to look pretty far away from the mouse. So this is like, I don't know where the mouse is, and it brings it back. So like unobtrusive features for people to augment their PC experience with, but not necessarily an accessibility feature. So is all the accessibility stuff in third-party packages? This is actually kind of annoying. Okay, yeah, maybe this is something you have to add as a separate tool. Is this a competing system? Or is this like something built on top of the Tobii hardware? Oh, okay, so Alex is suggesting either OptiKey or Tobii's product is called Dynavox. Gotcha. Let's take a look at those. Oh, but this is like, is this like a whole system, not just the software? Okay, so like this is the system that is probably pretty great, but is also really expensive, and that part of this project is trying to look for alternatives too, basically. Is there just the software though? What is just the software like? Is this the simplest one? It's a lot of dollars. What about this one? This is their new Windows control software, it looks like. Okay, that's the same price. Okay, well that's the state of that, I guess. What about OptiKey? Neat. Let's try this. Ah, GPL. It's weird that they make you accept it, because that covers distribution, not installation. I think I will. Oh, neat. Keyboard, pointing. I didn't finish reading everything it was trying to tell me. Oh, I think it's not set up for the eye control yet. How do I do that? Oh, neat. Is there a separate thing for setup? Not sure how to get to that menu. It doesn't seem to be click sensitive. Maybe I have to double click? Because I got to the quit menu somehow. I don't quite understand the restrictions on how my input events are handled at the moment. Can I get to that menu by right-clicking this maybe? Maybe not. Oh, there it was. Oh, how did I do that? Yeah. Nice. Dwell time. Alt-M is how I get back there. Okay. Oh, cool. Where's the backspace? Neat. That seems usable. Oh, and it's actually translucent. I just couldn't really see that super well. Cool. So that's how I can type. How could I, like, switch applications? I have audio turned off. I was trying to speak. Oh, there's the mouse button. Okay. Oh, neat. I can't quite look all the way into the corner. How do I make the magnifier zoom in more? Oh, I closed one instance of the management console. I think some of what I'm doing is probably off screen. I'm going to hide the overlay briefly. Oh yeah, I just have several copies of this open. Oh, now I lost the one that I was using. I think I closed the wrong one. Anyway, that was probably enough. Oh, can we get back there? Oh, this is the other version of this that was running with the mouse. Okay. So that was partially confusing because I had multiple copies of OptiKey running, but that seems super useful. So I wonder how this interfaces. I assume that this is using the Tobii APIs. It'd be really neat to see if this could run on like a Raspberry Pi with a big TFT screen on it. So is this where the trackers go? Data filters, native code. So we just search this for Tobii. Oh, points sources. So there's one for IX. Assume there's probably one for 4C in here also. Are the 4C and the IX the same in here? So these are the ones that we saw in the menu. Let's see who else is using this. I think we can close the camera. Oh, when I'm not even looking at that monitor, sometimes it gets some weird reflections. This might just be the menu. Yeah. Oh, this might be relevant. Whoops. I'm using the wrong search key because I'm on Windows. Okay, so yeah, the code in here that's labeled as IX apparently is just used for all the Tobii devices and the rebranded Tobii devices. Okay. So I assume then it's limited by the Windows API but this is great. So it means that maybe one thing I could do is to create another backend for this for OptiKey that would allow it to get points directly from Tobii 4C over USB, maybe with some other tool for calibration. So I'm curious now how feasible that would be. I mean, this is all still kind of in the phase of trying to figure out what's possible by taking things apart and figuring out how they work right now. We can try to figure out what is possible, both for open source software and just in general. So that looks useful. Let's try the USB analyzer. So everything's already been initialized, so this won't give us everything we need to know, but we can at least see what the kind of bulk, pardon the pun, what the kind of bulk data going through the device actually looks like. Ooh, what is all that noise? I think this is other stuff on the hub, so we can filter that out actually. And then this is the device we care about. There we go, filter. It's a nice little structure. A lot of what looks like 32-bit fields, huh? So, looks like we've got all of this coming in on endpoint 3 in. And then it's just like a stream structure in there. Looks like within endpoint 3 we have a few different sizes of packets, which is also kind of interesting. So this might just be like a stream of data from the ASIC that needs to be depacketized additionally. The USB packet structure may not be relevant or may not be the only packet structure we're worrying about. These numbers are interesting. That might be fun to take apart. What is the timing like on here? So we've got 5 12 bytes, 6 bytes. So these short packets are probably relevant. 512 is just the packet size that the hardware can handle. So anytime you send something back and forth, like a read or a write, it gets broken up into, a bunch of packets. If you have an arbitrary sized read or write, you'll usually end up with some 512 byte packets and then an additional small packet at the end. So that might be what's happened here. Sometimes it's more complicated. Like sometimes the different packet sizes can actually indicate different formats. But it looks like here, I think this might be the header, this thing that starts like 800064. So there's a header here, there's a header there, there's a header here. So this is actually just another packet that's shorter than the others. I wonder if this is a length. Yeah, I think that's a length. So I think this is another like nested packetization style here. My mouse stopped working. There it comes back. Interesting. So it'd probably make sense to collect this data and maybe graph how it changes, since it looks like a lot of this is static, but obviously some of it's going to change because it's got to include the gaze data somehow. And there's just a lot going on in here, so it might be worth having some kind of program that we could write to depacketize it. So in that case, it might be useful to figure out how to initialize it so we can see if we can just like have a program on the Raspberry Pi turn on the eye tracker and start receiving this data so we can start to figure out how it might be encoded. One asks, is Tuco about to fall off? He's on the edge. I think he's fine, but so what do we actually have here? So here's one of the 512 packets. It starts off with this 8, then the length, and a lot of other stuff, which could be measurements. This is also maybe a good time to think about what the data coming back from the EyeChip might actually look like. And maybe this isn't fully baked gaze data. Maybe it's actually something that reflects like which portions of the algorithm they ended up implementing in hardware. So maybe this could be something kind of like the Wiimote sensor, where the Wiimote, it was doing sensor fusion on the Wii to give you, whatever, like, Wii Sports tennis racket or whatever you were trying to hold. But the actual sensors, it had an accelerometer gyro built in. It also had this IR sensor that would actually look for multiple points of light in hardware. And so I kind of wonder if we're seeing something a little bit like that, where maybe the hardware is doing some filtering, looking for some structure which is relevant to the algorithm, and then just processing each one of those and returning them. So it could be there's like a buffer full of features that the algorithm has found in the image, and that's what this is maybe looking like. This is like the continuation, and then maybe the end of that structure. So I think these are all one grouping of data. And then this is a shorter group here. That probably means something different. And then another one of those longer groupings. These three, ending in a very little packet. But yeah, it would be interesting to just graph these. Let's see what it takes to initialize the device then. So let's stop this, get a new trace. And I'm just going to unplug this, get a trace from attachment. Is that not successful? I might need to restart my analyzer here. Analyzer, you having a bad day? Let's just restart all of this. Ooh, replugging the analyzer killed my mouse. That's not a good sign. I think maybe I need a shorter USB 3 cable on this hub. Host connected, that's what we want to see. Bunch of that noise. EyeChip, there we go. Filtered. And it looks like this is our data stream. Do we just need to turn gaze tracking on to get that? Yeah, there we go. Gaze trace. This looks like one of the positions. See that? It seems to move a little bit as I move my head. The number under the cursor. There's definitely an offset in the tracking accuracy as I move my head. Like, I'm staring at the tip of the mouse right now. But I can kind of center myself, and it gives pretty good accuracy. Okay, let's see what the beginning of this trace looked like. So all of this has been endpoint 3. So starting it up, we have all the usual descriptors, some of the not so usual descriptors. This is, anybody seen this one? The Microsoft Extended Compatibility ID. This is actually, if I understand, well, they might be using it. How are they using this one? I don't know if this is what they're using it for, but you can use these Microsoft descriptors to automatically load WinUSB without having to do a separate installation. So it's possible they're doing something like that. Yeah, that's what this descriptor is for. This is how you tell Windows to load WinUSB. Well, one of the ways. So it's getting descriptors, string descriptor, config descriptor, etc. Set configuration. So this is a useful milestone. This basically tells you where everything above set configuration, the first set configuration you see is the OS, kind of asking the device who it is. And then the set configuration and everything after it shows you what the driver is doing usually. So it's asking for the config descriptor again, which might just be related to it creating an endpoint abstraction of some sort. Then we see a nice little potpourri of control transfers and stuff to endpoints 3 and 5 up here. So this one, what? That's not a setup packet. Oh, that's literally just the setup. Okay, this is the setup data. A lot of times people call the setup packet this 8-byte. I mean, I think it is like a setup header or like a setup data structure or something, but then this is literally just the header that tells you setup is the next data packet, and then anyway, that's what we want. Let's get our decoder ring for this. Let's just grab the USB 2 spec. There we go. This is the thing we're looking for. So this starts off 4141, which seems a little suspicious. What is that? Yeah, that's vendor interface. Maybe that's just how you say hello. This is vendor specific, so they can make it mean anything. It's just weird that the request number would be the same as the request bitmap. It's kind of a strange choice. That might be how you say hello in some manner. Not really sure what that would do. And then we actually have some more output. So this is going out to endpoint 5. What are the endpoints we have total here? This thing over here actually tells you. So if the analyzer sees your config descriptor, it'll helpfully parse it out, and you can actually filter out traffic by particular endpoints here. So far we've got control transfers, vendor specific. We have out going to endpoint 5, which is this bulk endpoint. Then we have ins on endpoint 3. And so far we haven't seen anything on endpoint 4 out or endpoint 2 or endpoint 1, so that's interesting. I was assuming we might have something complicated on our hands because of all these extra endpoints, but those could be features that aren't being used right now, like they might be related to a debug interface or something. So that could make things easier. We just have outs, ins, and control. So then out, we've got this whole packet, 71 bytes. Looks like some 32-bit stuff maybe, and then some stuff that doesn't quite line up. And then as soon as that happens, we get a packet of a similar length here. Does that actually have similar contents too? let's just look at this conversation. So we've got 3 parties here in our conversation. We've got our control transfers, which I should open up a little bit. We need to at least see the setup phase from the control transfer. And then we have outs on endpoint 5 and ins on endpoint 3. Oh, and some of the control transfers have data. And one thing to look out for at this stage would be clues for the semantic distinctions of what they might have chosen to put where in the protocol and why. Wow, there's a bunch of stuff going out here. I wonder if any of this is firmware. I mean, it could be that the flash memory includes like a little bootloader, but then they send some more stuff that gets loaded into RAM. The only reasons I can think of to send a big kind of high entropy looking blob like this would be either firmware or calibration. This has some repetition in it, like it might be firmware. So what is the last thing that happens before all of this? Because this is the state we want it to get into. So we've got this collection of slightly differently sized packets coming in over endpoint 3 that presumably has the tracking data we care about. Looks like that was pretty soon after the firmware. Oh, I get confused by the scrolling direction sometimes. So this was a big delay right here, where it was waiting and the device didn't respond for some time. Maybe it was getting the buffer filled, because it looks like this stuff up here looks like the same as the stuff after the delay. So maybe there is a buffer, so it could be kind of sputtering as the first few packets come out. These seem to be the same kind of packets still. So this out might be the last thing that we send before the stream of packets comes in. Looks like that field changed that third D word, maybe. Oh. Also a change over by where I'm looking right now, that 4. Oh, this is an interesting packet. Yeah, so is this just going to be all related to this same blob? Let's try to find some structure here that we can use to figure out what this all is, and maybe if this is a binary blob, extract it. So it looks like we have packets with maybe some addressing and then binary blob in the middle. Yeah, 8-byte header. Let me just export all this to a file. And there. Was that not a continuous selection? How do I export a bunch of stuff? From... I think I need to select multiple things, though. Let's filter this to just n.5 out. Maybe the export just exports everything the filter is selecting. Binary. EP5 out. Ah. I think that's what we want. Let's see what that actually gave us. Do I not have that installed? I know I have XVR32 installed. This looks promising. Where are our packets? I mostly want to make sure that I understand what the boundary between two of these packets looks like, because that'll be important later in looking at this. This looks a lot like firmware, but it would be nice to see, like, what is that? That's repeated. I wonder if this is encrypted. I don't know, I kind of doubt it. I'm kind of curious. Let's just throw this in binviz right away. Yeah, maybe that is encrypted. That's not too surprising. But I thought I saw some repeating patterns in there. Let's see if this is just the data, the USB data, or if it included any of the, like, the USB PIDs too, because that would get in the way. So let's maybe find the first one. Interrupt vector table, anyone? That's interesting. Anyway, that starts with 3, 4 zeros, 10. This is missing some verticality. Let's go back to XVI32. I think that's the beginning of our packet. Four, five, six, 4D, CD2. Yeah. Okay, so that's the beginning of this packet. Now let's look at the end of this packet and see if this matches up with what's before it. Looks like it. Okay. Just had to make sure this wasn't including other bits of USB protocol that would have gotten in the way. But this is just the packet payloads all jammed together, which I think is what we want. How can I group these? I mean, we don't really have to understand this blob to make a Raspberry Pi driver for this thing. You could just figure out how to extract it from the Windows software and then resend it. So in fact, because like legally you don't really want to redistribute this because that can really easily get you into copyright trouble. But making a tool that lets someone use this thing that they've bought on a Raspberry Pi by extracting the files that you need from the Windows driver, that, as far as I can tell, is completely legal, and lots of people do that without any trouble. So that seems like a good approach. And if we go on the assumption that this is firmware, then the next step toward that goal would be to figure out where this exists in the Windows binary and just make a little extractor that people can use. I mean, just for research purposes, we could just suck this out of the USB analyzer, since that's also a viable option legally. It's just that people don't usually have a USB analyzer if they're building something that you are distributing on the internet, you know? It's nice to give people an option that, you know, it doesn't require you to host any copyrighted materials, but still makes it easy for them to get the file they need. This part might be some more clues just about the overall structure of the packets. Like, it looks like it's got a header with maybe a command in there, and there's probably just a command that's like, write this stuff to RAM. Just catching up on chat slightly. Is my dump including the packets that are nagged? No, it shouldn't be. And then Alexia's talking about this being... So, this is not necessarily a case where Windows is necessary, you know? I mean, I understand that Toby does a lot of stuff that is useful for Windows, but my goal here is to figure out how things can be repurposed, so... It seems likely that there are probably a lot of other applications where people need a bit of assistive technology that doesn't fit into the I have a Windows laptop use case. Last time we were looking around, it seemed like the firmware would probably be in a pretty easy to find place. Nothing was really positioned strangely in the software. I assume it would be in either of these. What is IS3? This might be something different. WinUSB anyway, so. Here's some firmwares. I don't have an actual Xtop tool installed other than XVI32, I think. Let's see if these look similar. So the point where I would expect the firmware to start would be, yeah, like around here. Some of these may be address-looking things. Let's see what these look like. I don't actually know which of these is relevant. I series, large. Those might also just be for different devices too. Here's something, IS3. Laptop peripheral firmware. And you could potentially run the service with like process monitor or something and see which files it's reading. I don't think this would be it, but is it one of these IS4 devices? These are all about the same size. This one's a little larger. This also is probably packed somehow. Oh, look at these options. Encrypted version 1. Do I have a grep on here, an echo? I would really like some command line tools, but this is Windows. I don't think I have any of that installed. Maybe we transfer this over to the Mac and do some stuff from there, where I have more tools. Yeah. That was elsewhere. Yeah. Let's maybe save this whole trace too. Only 25 megabytes. Okay, let's swap over to the Mac. I haven't really been keeping up with what Alexi's been saying. I mean, from what I'm seeing, it looks like there's just a bunch of reasons why not use Windows. It's kind of seems like. I mean, maybe people use Windows a lot, and that's fine. But I mean, I think this is something where I want to open additional options so that if somebody wants to make like a gaze accessible device that you can like walk up to and use, or that you can like carry with you, that isn't in the form of a Windows laptop, then I think it would be nice for people to have options. And it doesn't seem like that technically hard of a thing, so I mean, that's what this is. It's an investigation to see what the options are, and so far it looks like it would be totally possible to get one of these trackers working with a Raspberry Pi and a small monitor. So, like, you know, I don't want to like disparage any of Toby's efforts. I mean, I'm sure their software is great, and I'm sure their hardware is great for the people who can afford it. But I also just, you know, believe strongly that if you have a device, you should be able to research it and figure out how to make it do more things. And so that's what I'm also trying to show here, is that whole process and the results, and trying to make all of that more accessible. All right, so here's the files we've got so far. I wonder if I can open this with Data Center on the Mac. Are we past the age of file formats that are different depending on what platform you're using? This looks like a Qt app, so it's probably going to be pretty much the same. Can't do that, though. Cool. And we've got the devices over here still. Yay. All that good stuff. Oh, I guess I am missing some stuff in chat. Let me go back and see what chat is trying to communicate that I'm missing. Oh, a capacitor got knocked out. Ooh. Oh, was that mine? Well, geez, huh? Interesting. That could be a problem. Doesn't seem to be so far. So I get that there's a Linux package in development, which that'll be great when we have it. That doesn't keep me from being curious or wanting to show people how to understand hardware that they're using. And it also doesn't really help people right now. So, I mean, that might certainly change how much effort I put into this project, but at this point, I still want to know how this thing works, and that'll tell me like what the next steps are. Oh, it looks like Toby has a GitHub too. Yeah, I think we looked at this before. This is really high level stuff. What is this? Core SDK. Where's the code? Oh, these are samples. This isn't actually an SDK that's open. I mean, sure, this is code. This is not enough for people to port the tracker to a new platform, but it's not nothing. I'll give you that. Oh, I wonder what that capacitor might have been. Alright, I don't have time, or I don't usually want to watch other people's videos like on the stream because it seems like plagiarism, but that video might be useful just for other people to see what Tobii Dynavox is actually doing. I'm sure it's great software, I just want to have other options. Oh, so that, I just noticed that other circle, so the capacitor might still be lingering somewhere. Oh, geez. I'm going to unplug it just for now, but yeah, I'll keep an eye out for that capacitor. If I can't find something, I might just throw on a couple of microfarads and assume that that was probably just something to stabilize the DC converter. Hope that that hasn't done any damage so far, but at least it seems like it mostly works without that. Anyway, let's look at these files. Oh yeah, James wonders if that capacitor coming off could have made the USB flakiness happen. That's certainly possible. Anyway, let's take a look at EyeChip. Cool, we're seeing all the same stuff from Windows over here, except I'm having trouble resizing this. I don't know why I can't resize that. Anyway, same thing, endpoint 3, endpoint 5. Cool. Maybe I'll save out endpoint 3 also, just so we can take a look at that. Because this is going to be the resulting tracking data, and it might be nice just to look at what we've got. And that might tell us like how much software is necessary to build on top of this. Like, is this pretty close to an eye gaze point that you could feed into something like OptiKey, or is this more like, you know, just like tracking blobs that you then have to feed into another kind of middle layer of the algorithm? So that might be good to know. This is EP3N. Tracking data, and mostly firmware, I think. So what I want to do next is to see if I can search for any of this and find just verbatim chunks of it in the service directory from the Tobii software, and to see like where would it be sending it from, and that's like where you would end up grabbing the code so that you could then stick it on your Raspberry Pi. So let's have a new terminal. Can I do this? There also could be an encryption step in between, perhaps, or it could be not in this directory. Another option is to look at how the service goes about loading and try to break that down into parts and see if we can isolate where the firmware upload happens. Yeah, so that doesn't seem to be a direct copy of anything here. Oh, maybe we're going back to Windows. So, I mean, everything that does the low-level USB communication, you would expect to be in this directory because that's where they're including the libUSB copy they're shipping. Who's mentioning libUSB? Firmware download util. Well, how applicable is that to everybody else's thing? I wouldn't be surprised if there are actually multiple firmware update mechanisms, and this is only for some products and not others. Yeah, because, I mean, this might be for something that you run, like, and this is mentioning IS3, which I think is an older version of their product. This seems like something where we're just writing it to RAM every time the driver loads, so it might just be part of one of the drivers. So libTDI DLL, I think, was the imaging driver, basically. Although it might certainly be responsible for non-imaging. Because, I mean, in the IX, that DLL was doing the USB communication, and it was sending frames of images off to another thing that was running their actual computer vision algorithm. But maybe there's a different role that that takes on in the 4C software, or maybe it's just unused. What about is that another firmware upgrader? Ha, libgcj. That's a way of compiling Java programs. I'm assuming IS3 is an older version of the tracker. Oh, is that a reference to SciUSB? Yeah. So this is something with a Cypress chip. What about libTDI DLL? Is that one going to maybe have references to this product separately? Because I only really looked at the IX parts of it before. It's also possible this isn't firmware. It's possible it's configuration or calibration data. See, this is talking about FX3, which is the chip that the IX uses. But it also seems like they're supporting multiple models here. Harry, huh? I wonder who Harry is. So the OmniVision stuff probably refers to the driver for their camera chip. It's quite possible that for the visible camera, they're just like passing through whatever OmniVision protocol that chip supports. I looked at this a little bit before, and it seemed to be pretty much all video. It would be nice to know what user space process is communicating with a USB device in Windows. I wonder if I can do that. I also wonder if maybe they just designed this so that maybe the 4C is a different frame format. So maybe this still thinks of it in terms of video frames, but maybe instead of being frames of video, they're actually frames of like pre-processed shiny locations or whatever it is they're looking for. But it would be nice to know if this is the driver that ends up actually setting up the device. So I know we've looked at this before, but let's remember who actually calls TDI DLL. iController core, gotcha. So is that still running? Let's go back to Windows. Wasn't that controller core? Now we've got all this other stuff. So let's try to figure out what the minimum set of stuff we need is for the controller to be initialized. I might not worry super much about the capacitor right now. No, let's fix this. I'm nervous about running this without that capacitor. It could cause other damage. Let's maybe give this thing a really quick repair job. Oh, nice. Sodium has discovered that the IS3 is the code name for the one that uses the IX, and the IS4 is the one with the ASIC. Wonderful. That should be super helpful. Man, and good eye spotting this capacitor. That's pretty nasty, isn't it? Just running this thing without stabilization on, is that the input? That might be the input capacitor, so maybe we were, like, that could explain why the USB cables couldn't be so long though, couldn't it? Let's just see if I have like a couple of microfarad ceramic to put there. Oh, here's a 10 mic. Trying to follow that comment about the I'm mostly going to laugh if you're going to try to enforce or tell me that a click-through agreement is enforceable. I mean, reverse engineering for interoperability purposes trumps click-through agreement. Oh, that's a little big. That is not a 1206. Do I care? Does that fit anyway? I think that's probably actually way too big. Yeah, let's find something smaller. Oh, I've got this nice collection of 805s. I think these are mostly small, though. Oh, here's a 1 mic 10 volt. Let's try that. And maybe I'll hope that my soldering iron's actually plugged in. I win! The soldering iron's plugged in. Now the question is, which handle is attached? I need to clean up these pads slightly. Maybe tape this down. Go, little ground plane. You can do it. Okay, maybe the other soldering iron would be better for this job. That ground plane. Yeah, let's get some more heat. Let's tack down the other side. This might not be the prettiest fix, but it should keep this from getting worse. Oops. Ooh, this has got a lot of copper behind it also. Well, copper and aluminum in this case, jeez. Oh, I forgot to move the soldering iron sleep detector thing to the other stand. The soldering iron was going in low temperature mode too, which I'm sure didn't help. Oh, that's nicer. Helps if I use the tools correctly. More success, less silly mistakes. All right, I'm gonna let that be. Maybe I'll clean it a little, but I'm not gonna fuss with it too much. All right, let's maybe try some more investigations now. Now that I'm not going to worry about the power supply destroying itself. That's going to need a lot more tape. Oh, Tuco, what is going on with your fuzzy butt up there? Let's readjust that camera too. Oh my god. Oh. Oh, that's a good comment from Sodium, actually, that maybe that wasn't really a capacitor. And then Chris adds that that might be a 0.47 ohm resistor in parallel with it. Ah. Well, let's take a closer look at that circuit before plugging this in. Is that in parallel, or? Oh, yeah. Yeah, You think that's for stabilizing a current feedback loop? Oh, let's try to find a data sheet for this converter. This is what? P2310. I mean, I have another one of these, but it would be nice not to open it up unless I have to, since the opening process is apparently a little gnarly. Not quite sure what this chip would be. Yeah, that needs more focus, doesn't it? I'm not seeing this chip. What could that have been? I don't still have it just hanging out on the desk, do I? I mean, we could start probing around in this thing with the O-scope. I'm also just thinking about where to go in the stream, I think, or I mean, not just in the stream, but like in this video that I'm trying to edit together out of all this. Because it would be nice to at least demonstrate, like, here's some data coming back from the gaze tracking on a Raspberry Pi. And I don't necessarily need to make an awesome firmware extraction tool to get there, but it would be useful to at least know where the file comes from if it is indeed firmware. Oh, that's for the LED driver. That isn't the main input buck converter, is it? Because that trace is going right at the LED through that ferrite. So that looks like a current sense for the LED. I wonder if that capacitor was just for EMI. It probably does need to be a capacitor, but maybe a smaller one. P2310. There's got to be some kind of LED drive. I might just leave it open, not worry too much about it. I'm just annoyed by the mess right now. Alright, well, unless anybody has some ideas for what I should do with this, I might just leave it open. It's frustrating, but... Oh, interesting. Let's get a closer view at that screenshot. It does look kind of resistor-y, doesn't it? Is it just maybe a second power resistor? I don't know why they would be doubling up on... I mean, unless it's just like double the current sense resistors to spread out the heat load. Can I find another structure on the other side? This is... I mean, there aren't multiple of these regulators. This must be shared between all the LEDs, right? I think I'm going to note that, not worry about that too much. That'll be this device's first quirk. I'm sure it might develop other quirks later. Well, so we could try just replaying this traffic on the Raspberry, but I think it is worth at least a quick look to try to see what part of the Windows software does this setup. Yeah, I think it's 0805. That does look resistor, doesn't it? Like the thin film on top? Oh, current sharing resistors. I mean, if that was the case, I would expect one of the LEDs to just not be working. And it looked like they were all flickering. Let's take another look at this, though. So let's get a new trace. Aggregate. All right. There's a new EyeChip in town. All right. Let's see if we can start disabling stuff and get the same results, or see what the results do. So I think if I just start killing processes, though, they might respawn. I mean, like, what about the tray? And IX interaction. Just leaving service and engine. Well, they haven't respawned that I see. I think I'm just filtering them out right now. Yeah, there they go. Man, all this noise from the hub certainly is annoying. Now my mouse is having trouble. just don't see this updating the list of devices anymore. This might be... Yeah, I'm getting some communication with the new device. So here's the one I just plugged in. Sending the binary blob. But then actually we're not continuously polling. So will this resume if I actually start one of the other processes? So the tray thing is not running. And so we've got engine and service, but not interaction or tray. Is this the gaze utility, gazenative.exe? That might be something else. That might just be the native code portion of something that's mostly in .NET. Okay, if I run just the tray, now it says connecting. Are we still running without the interaction exe? Or did that restart? Oh, that restarted interaction. So that might be some service that the higher level stuff ends up needing. But the device initialization happened just fine without it. So we're looking for something in service or the core. And I think IX engine is a C# process. I don't know if service is. Looks like they probably both are. IX engine. Oh, there's a bunch of server.config files. That's interesting. These are encrypted. I wonder if these are encrypted using the same tool that encrypts the firmwares. IX controller core. Where's this ix.engine binary? It's in the ix directory. That's interesting. Config. wonder if the device, I mean, I can think of a lot of reasons why it wouldn't, oh, togi.firmwareupgrade.net.pdb, stream engine. I wonder if that ends up getting used. Like, it would be nice to figure out how to get this running in kind of a minimum configuration. So will that one restart? Okay, well, I guess I have the service no longer running and just the engine. That looked like the WinUSB driver bound to it, but it didn't do any of the subsequent stuff. So that was without the service running, so I guess the service is at least necessary to orchestrate that. Can we try doing this with only the service running? So what if we get the service back by restarting it? Oh yeah, Sodium's wondering if that Toby config binary that it was mentioning actually exists anywhere. I haven't seen it. I assume that's something that's part of their build process and not something here. It's all the config-like stuff. Okay, service running. Okay, so kill the tray, kill interaction. This time I'm also killing the engine, so we just have service. Looks like it isn't restarting the engine by itself. That looks similar. So it might be something where the engine and the service talk to each other. My guess is that the service would be how all the different parts communicate with each other, and the engine might be what's doing actually the work here. So this is the previous generation. So what did we see that said IS4 on it? Is that in the service directory, one of the firmware files maybe? There's a bunch of IS4 firmwares. Where would we find the names of these files, maybe? Maybe that's the thing to look at next. Alright, so the IS4 firmwares might be what we're looking for, although these didn't seem to match the traffic that we're seeing on USB. So where would we find the names for these? Let's take something maybe distinctive, like large Toby peripheral. What if we just look for that string? It might be in... Well, let's maybe grab the other files too. What is the best way to get grep on Windows? Because I would like to not have to keep going back and forth. I don't really want to use Sigwin. Use MSys. Yeah. I'm missing some more useful tips for Windows. Oh, bash on Windows. I mean, I don't really care about the shell so much. I care about the tools like grep. Mm-hmm. That seems useful. I don't think that's it yet. Do we not have the necessary version? I know I updated the other Windows machine to the creators update. I don't know if this one has it yet. Ooh, this needs a newer build. So I didn't update Windows on this machine. I updated it on the streaming machine. So this one might still be waiting on the update it needs. It's okay, Vim is installing. Yeah, that's weird. Pretty old build number, but it says that this one's up to date, so I guess it hasn't decided that I get the new build yet. A lot of text files in here. These are licenses. Poly. Yep. Can I start using this yet? Oh, is this done? Do I have any of this in my path yet? Is that going to take effect if I get a new window? Most of that's in here. Yay. Now I'm going to really be lucky if it has an option for wide strings, but I don't know if it'll come to that. Oh yeah. See, and this one's different. This one has a capital IS4, but it probably doesn't matter. It might also just be enumerating all of these packages and then just looking for some signature that it's trying to find in the header. Ah. Configuration. Wonder why those are only in the PDBs. Oh, there's a whole separate directory. So the firmware is included in here and in there. There's a bunch of firmware packages here in service. And then there's a separate Toby firmware directory. Who knows about these Toby packages? Firmware upgrade 32.exe. Well, what do you know? Who knows about that? I mean, I'm not really expecting this to be a separate exe since this happens just every time you plug in the device. But this might give us some clues for how things are structured. Two different firmware utilities here. Oh, that's nice. Got some certificates in there. I think we looked at this one already. Boost. Maybe we didn't look at this one. I wonder if they need all this network stuff for firmware updates. Well, this takes Toby package files, so this might be a way to figure out what those files are like. Does this do anything if we just run it? Info only, maybe? Oh, and it can download them, so I guess there's an update service, maybe? This, seems an interesting place to check. So we know that this is an IS4 large peripheral now. Cool. So this program might be a good thing to look at if we needed more information about how all of the kind of internal model numbering and everything works. Toby TTP. Ha ha ha. And what if I tell it to run without info only? Can I give it the firmware file and watch it install it? And then try to... Can I maybe use this on its own without the service running? Maybe that would be an interesting thing to try. So, large peripheral. There's large Toby peripheral, large peripheral MSI, and just large peripheral. Oh, it needs a URL and a Toby package file. Maybe the URL is just the way of identifying the version. So auto to identify the version automatically, then use that file maybe. That seems right. This is also much slower than what we were seeing before. And we got a transfer error. And the device came back. So it might be that that blob we're seeing is not related to the firmware at all. Let's see what it looks like in the USB analyzer when we do actually send firmware. And let's do this with the service not running. Let's just not run any of the software except what we're actually running in the command line here. So Toby service stop. And no Toby binaries. unplug it. Start a fresh capture with no filters. Plug it in. Select it in the filter. Okay, so now we're seeing Windows has identified the device and the WinUSB driver is loaded, but we haven't actually started communicating with the device at all. But this will be live scrolling when new updates happen. Then let's try the same thing over here. First let's try identifying the device. So this will be auto and info only. No tracker found. I wonder if this is trying to communicate through the Tobii service. I guess we could figure out pretty easily by disassembling, or not even disassembling, but even just looking at the imports and seeing if this is talking to libUSB or to other processes. Let's just try replugging this just in case, but so with it completely unplugged, this says no tracker connected. And this plugged in. And with the service running, let's reset the filter. Okay, now this whole thing is running and like it's gathering telemetry from my eyes. Or trying to, even though it's pointed up at the sky. Yeah, all the LEDs are blinking. Okay, what happens if I just leave this running and try the firmware update? It aborted some transfers. I really did not like that. I wonder if this is trying to communicate with the device at the same time, and that's not going to end super well. And what even is this? This is just a setup transfer with this little 16-byte data buffer, which might be a firmware version or signature or something along those lines. I don't know. Let's maybe take a quick look at what this program is trying to do. This is firmware upgrade 32. So imports, some crypto API stuff, making hashes. Kernel 32. What is MSVCP? Oh, Visual C++. This is IOStream, and this is the traditional C runtime. Sockets. And no USB. So I would assume that I would see some inter-process communication where this maybe... I'm just trying to imagine the architecture this implies. Like, would this be sending a command to the service to say, update the firmware, or would it be sending a command that says, please forward this low-level USB command to the device? Either of those seem like they would have some interesting problems. Where are we at with strings? That mouse is not having fun times. Oh, James in chat points out that there's a firmware file parse.dll. That sounds useful. Yeah, this seems to be pretty spread out across different parts of across different binaries and different modules here. Upgrade protocol. I wonder if they're FTP? Huh. I mean, it wouldn't surprise me if this talks to an update server. FTP is a little strange, because that's often hard to get through firewalls. These might be paths, or maybe this is about the inter-process communication. So I'm assuming those Toby packages are probably encrypted. Well, I'm pretty sure they're encrypted. I'm not totally sure whether the decryption happens here or on the device. It might be both. Like they might have one layer that's done here and then one layer on the device, which would be super annoying. Pipe firmware upgrader. XDS. Is that how we're communicating between processes? This is definitely some IPC stuff happening here. Named pipe transport. Oh. Interesting. Maybe there's a pipe associated with each eye tracker. I'm curious what this Toby TTP actually means. Like, is this identifying a particular tracker or a particular tracker model? Anyway, I assume this is just going to be doing a bunch of IPC. More objects. But I would be surprised if if this binary is at all involved in when I plug in the eye tracker. I really doubt this actually runs. I suspect this is just used for something else. I still don't know whether that blob that we're seeing is firmware or not. It might be useful to see what files the service ends up reading. Can I run a service on the command line? Like running service host directly, maybe? I mean, I think that there's a completely different context that services have to run in, so I'd be surprised if... I forget, it's probably something for the MSDN documentation. Like, how do you debug a service? Command line. Yeah, I know about using net.exe to start and stop services, but I'm curious if you can actually run it from inside the console. Attaching. Is this config file another one of those encrypted things? No, this is XML. Using some off-the-shelf stuff, it looks like. So is this logging on behalf of just other applications? That's what it looks like. That's weird. Do I have Windybug on here? All right, we were in this before. Yeah, how does that work now? So we tried running this as administrator before. Right? I don't think this actually did it. Oh, that did work. Cool. Oh, for the question about the stream archives, yeah, YouTube does an automatic stream archive. There's kind of a weird period, that it goes through where, like, right after the stream, you can see only the last 2 hours, I think. Then there's a period where it isn't accessible at all, and then finally they upload the whole thing. All right. So, threads, where are we? Let's have a call stack window. Oh, wow, 64. I guess I need to be using the 32-bit version of Windybug. Let's try that. Did I kill the process? I probably did. Come on, mouse. Oh, I'm having such bad USB karma today. This is probably just my mouse and the USB analyzer fighting for bandwidth. Oh. Now I'm having stupid Ableton problems on a monitor you can't even see. Really hate how when Ableton runs out of disk space, it actually turns off the arming for a track. So when you hit record again, you can't. Anyway, Toby service. Okay, is this going to be any better? Threads. Maybe they won't all be WoW64 emulator threads. Oh, this is a CLR app, right? So that's cool. We can still set native code breakpoints on libUSB stuff if we want to go down that route. Oh, here's WinUSB. libtoby WinDLL. Huh. So I guess that tells us what we want to know. There's a thread in the Toby service that's just sitting there listening for USB incoming messages. Which pipe is it reading? libtoby WinDLL. Where is that? Oh, there is like literally a thing called libtoby WinDLL.dll. Great. I guess that's just all the native stuff that goes in the service, or maybe this is used elsewhere. WinUSB. Man, that's interesting. So they have a libUSB binary in here, and I know that they're using libUSB for, like the code that we saw in the IX was using libUSB, but maybe their newer code just skips that and uses WinUSB directly. I guess that would make sense if I mean, this device was clearly designed for WinUSB. It answers the descriptor requests and everything. So anyway, we've got control transfers, read, write. This seems useful. So the place we were just at was in one of the read pipes. I'm curious which pipe that was, so we might look at the endpoint number. This also, like, if this is where that binary blob is getting written, that might be a way to figure out how that's happening. So read pipe called in two places. So one of these arguments we could probably trace back to figure out which endpoint this is. Oh, it's a one-character pipe ID, so maybe that is just a number. Yeah, this is the USB endpoint address. So that's just the second parameter. Is this fast call? What calling convention is this? Standard call. So is it this one. Man, it's been a while since I've disassembled just plain old 32-bit x86. This is probably some internal library that we're going to find call sites to it that have an actual endpoint number. Let's see what the other invocation looks like, and maybe let's label this one. USB read wrapper. Oh, these are both here. Okay. Ah, that's just blocking versus non-blocking, I think. Okay, so where's this called? Is this an export? Oh. I'm guessing this is setting up a thread that does the USB reads in a loop. This is passing around a bunch of function pointers to make that happen. Let's take a look at write. That's a lot more straightforward. Kind of a fire and forget versus a a big overlapped operation thing for getting the results asynchronously. Oh, and this is called several places so far. Well, at least one big function and one little one, it looks like. Oh. Memcopy free. This looks like a compatibility layer for something. Are we? This might be just a general purpose thing that shuttles data between a pipe and USB or other destinations. What is this one? Maybe some in-memory buffer there. This might be like their main pipe that they accept commands on. I'm gonna guess this is like an incoming command pipe. Oh, pipe server. Oh, these are thread structures. These are like names of threads. This is the pipe server thread. This is the WinUSB read thread. And this is the time sync thread. Whatever that's for. And maybe this is the SCP, although that doesn't seem to have the thread function. Interesting. So write pipe again. Write wrapper. So it's used in pipe server thread. So I'm guessing the reason we're seeing two of these is the write wrapper probably gets called directly by the pipe server in case it's got like an encapsulated thing that just gets shuttled off to USB. But then it's also got this other function that's calling it a bunch of times. Oh, that's interesting. At the end of this seems to be queuing a response. Oh. So these are asynchronous procedure calls. This is saying like, it's like a set timeout in JavaScript. One thing that would be nice to do is to maybe trace through in WinUSB write wrapper and find the endpoint number. I'm wondering if it's this 4 right here. That could be some functionality we're not currently using then, if that is the endpoint, because right now we're seeing input on endpoint 3, which would show up as 8.3 in the code in USB terminology. And then this output binary blob, which I'm currently curious about, is endpoint 5, which would show up as 5 out. And it's possible that this doesn't actually send it, it just acts as a conduit for sending it. And someone else is going to be packaging that stuff up into the right format. So WinUSB write wrapper, WinUSB write pipe. Let's see if we can actually map out these arguments. So that's basically what we're looking for. So I would expect this overlap to be null since I don't think we're keeping track of any overlapped operations. So I think that's going to be this. No, that's the length transferred. This LEA would be getting a pointer to that. So this is length transferred. Is that the interface handle? This is a very thin layer over the WinUSB write. I'm mostly interested in this pipe ID. What are these offsets. Oh yeah, this would be the byte. That confirms it. So that's the second arg. This is sine extending a byte to a 32-bit value, so this is going to be our endpoint. So dx or dl or something in there. This one, second argument. I think these are very similar to WinUSB write pipe. This will be the interface handler. That's the pipe ID. So in this function, yeah, ESP+4, this is the pipe. So this is endpoint 4. Let's see, are all of the ones in this function endpoint 4? Because if so, this might be interesting, because we haven't seen any of this. This is something that is not occurring in the wild as far as I've seen so far, which means avoid it now, but it might be interesting later. Yeah, so this is interesting. This is writing to endpoint 4. We want endpoint 5. That also might mean that endpoint 4 is for some kind of lower level functionality in the device that maybe the service itself would want to write to, whereas the other stuff is potentially delegated to a different process. That does mean this is probably coming from across this pipe server. Oh no, all of this goes to endpoint 5. Oh. Cool. Is that the only one here? Because maybe we're getting closer than I thought. Interesting. So maybe this is what we want. Okay, where does the buffer come from? So buffer is the next argument after the pipe ID in WinUSB write pipe. So that would be here, ECX, arg8, yeah. EDI. We just mallocked it. Is that true? So this malloc returns in EAX. We're testing to see if it's null, and skipping this if it is. Otherwise, we store this in EDI, which sticks around until down here. And then we immediately free it. Okay. And then, is EDI used for any of this? Oh, maybe we're relying on the oh yeah, we're probably relying on this staying in EAX. Cool. So yeah, that's... Oh, so they save the buffer we just allocated in this little temporary just to get it out of EAX, but then they bring it right back. So this is copying to the buffer we just alloced. Where's the size? ECX plus 8. Anyway, that should be the source, and that's the size. So up here, the size was that plus 8. Oh no, and then we saved that. So that's the allocation size. Back in CX. So we are filling the whole thing. Then where's this coming from? LEA EDX plus 30. EDX plus 30. Is this going to be like an incoming buffer from somewhere? There's got to be some big data structure that maybe came from the file or the network. This is like some kind of incoming command processor, which is kind of what we expect because I think this is the main like incoming command thing for the service. What does this even export? Get device name, GUID, init, receive message, start async. This looks like a pretty minimal driver for this device. It'd be really nice to make something like this that is cross-platform. Log message available callback. I wonder if that's one of the endpoints we haven't seen used yet, if that's for logging from the firmware. Feels further away from what we want. If we knew which named pipe this was, we might be able to figure out who's on the other end of it. So I guess this is the Toby blah blah blah. I mean, how many pipes are there going to be with Toby in the name? That's interesting. So this might just be a general purpose way to shove data into endpoint 5. So far, this is not looking like it's necessarily the firmware. I wonder what else that blob could be if it isn't firmware. Is it an encrypted config file? I mean, I guess I could take multiple traces and see if they change. I don't know if they necessarily would, though. Like, I don't know if that would be like user configuration. It seems more likely that it would be specific to the version of the software I have installed and maybe the model number. G6 receive message. It's also possible this pipe is used internally in the DLL. Because one question I have is, okay, so you're writing a DLL like this, and it has some boundary between what's inside the DLL and what's outside. Is this pipe for communicating between the threads in the DLL, or is there a way of getting access to it externally? And I was assuming that it was external, but I'm also kind of curious about this stuff. Like, how do we get to the point where we're actually in this pipe server thread? Like, who starts this? We saw it in this data table. Oh, this is the very beginning of the data segment. Offset 6 EAD. Is this the thing that starts multiple threads? I mean, we could also start pulling at the other end. What is it? Create thread. Oh, are they using p-threads? Huh. Begin thread EX. There we go. I don't know whose thread wrapper this is, but this is somebody's create thread function. Oh, watchdog thread. It has a separate way of being made. Great, so it looks like this function is responsible for creating all the other threads. That's a big ol' switch. Check that. is this? Ah, G6 start async, receive message, or something else. Ooh, wide char to multi-byte. Or something that's called from receive message. Interesting. So that start async thing seems to be where we actually get into stuff. Maybe the pipe is internal. Q-sort. It's interesting. It's not that often you see Q-sort. Where is our thread function? I don't see the thread function we were just looking at. G6 start async. What do we call this function? Oh, this is like some kind of really heavy-duty init function. We call this big init. There's the watchdog thread happening pretty soon. Some of this might be trying to figure out what kind of device it is. That was something about the serial number too. Where is this called? That's what we were missing. Tail call. Huh. I'm not sure why I'm not seeing big init showing up there. Anyway. Would we be writing to a pipe, maybe? What I'm looking for is, or rather maybe what I'm expecting / hoping to see is something like a function that is accessible from these top-level exports, which then writes back into that same named pipe. We could also take a look at who's using this start async and see how it's called. Since I think this is going to be useful to see how this all starts up. they might be importing this by ordinal number, though. And this is probably being called by C# code. Oh, there's a reference to this in text.hid.dll. I wonder if that's a different product. I don't see anybody else include the name TobyWinDLL unless it's encoded in something. Oh. Yeah, we do want to stay in this directory. Can this do wide strings? No. Oh well. That's interesting. So maybe this is indirect. Maybe that's set up by this text.hid thing. So maybe let's take a look at what that does. Hid, host, and light. Interesting. Uh-huh. That's fine. I don't want to load that. That's cool. It was going to try to actually load that into the address space, I think, but I'm fine with an import. Oh yeah, this just has ordinal numbers. But if we actually go to the other file, let's just open another instance of IDA. So we were interested in start async, which is ordinal 7. Here it is. So that does make a call to the function we care about. So my next question is, what is this? I mean, the name hid would imply that maybe this is or was at one point designed to talk to a USB hid device. We've got some months. Got to make sure everyone has a copy of those. I. Hid I. Is this just a wrapper? Hid I start async. Is this just going to call the other thing? Okay, fine. Fine. So I guess somebody is calling into text.hid.dll, but what's actually going on is this TobyWinDLL stuff that we've been looking at. So who knows about text.hid? Controller.service.library.dll, and that's back in C# code. Controller service library. I wonder what IDA does if I open a CLR DLL in there. I don't think this version of IDA is new enough for that. Controller service. I haven't looked at this file at all yet. Oh, this is not CLR. This looks like native code. Okay, then I guess it is native code. Imports, text.hid, text.host, text.light. These all seem to be similar plugin interfaces. Start async. TSI start async. And is this just what this exports? Yeah, man, these are the tiniest DLLs. What does this even do? Like, what is the code for? Are there any strings that hint as to what this is for? I mean, this looks like just some infrastructure that lets them, separate out all the different products into little compartments. It's just kind of a little bizarre looking at it from the outside without knowing how the development of this all was structured. Well, anyway, TSI start async. And this might even, well, given that this directory is labeled plugins, I'm wondering if there's some uniform way that these are all loaded. Let's just see if there are any references to TSI start async. Well, we have the IX controller. That seems, I don't know why, what makes this a plugin then? There's the controller wrapper and the service library. I wonder if either of those are native code. Oh no, those were also in plugins. Service, interesting. So does this import from its neighbor plugin there? Does this have no imports? Oh, this is, oh. IDA is trying to disassemble the C# code. Cool. I've never done CLI code before. So we have function names. Is this a C# wrapper around what we were just seeing? Because this has a function called TSI start async. pinvoke implementation. Okay. I think this is just going to be a native code wrapper, maybe? So can we tell who calls this? Start async. How do I follow cross-references in this? So that works. Kind of. I don't know how oh, is this the code ref? I'm not sure what I put my cursor on when I press X to follow this. But double-clicking that works. Can I get references to start async? Is this something we're exporting? Is this just a standard thing that all the plugins have? Maybe that's just a normal plugin thing. Maybe all the plugins know how to start async. System reactive. Toby service plugin. Let's try that. Yeah, okay. Yeah, so maybe that is the plugin interface, so maybe all the plugins know how to add async. And I think we're just slowly uncovering the infrastructure that you would use if you wanted to add a new type of eye tracker to their daemon. Oh, that's really cool that this disassembles CLI. I don't get imports and exports. Oh, there it is. Start async. Call virtual instance. iToby service plugin. And where are we? Start all plugins. I don't seem to have good cross-referencing in CLR. I don't know if I'm just not using this right. Text search works, but I would expect that to be pretty slow when these files get bigger. Okay, maybe that's called elsewhere. Service. Function run. Cool. Huh. This is like the service class, whatever it is. Namespace toby.service, class toby service. Well, that doesn't really tell us how to send messages to this. It just tells us there's a lot of layers of abstraction in between. It might be instructive to know if this program knows about named pipes on its own. I would really expect that to be in one of the lower level libraries, though. Like, this all comes back to here. So we were just following who calls TSI G6 start async. And so there's a plugin interface, but then eventually it gets called by the main run function in the Toby service. So this will be running inside the service process, which is a mix of C# and native code. But then this starts a bunch of background threads, including a thread that's processing messages from a named pipe. Some of those messages seem to turn into the USB out requests on endpoint 5. So somebody else in this whole inter-process communication system is responsible for generating those binary blobs. I just don't know what that would be from yet. Oh, let me catch up on chat. I haven't been paying attention to that lately. Firmware file parse. Yeah. Oh, I've been wanting to set a stream up for Twitch, actually. Like, I had a simulcast for a while when I was doing stuff with Senrio, and I think I'm just going to take that same setup and run it on my own account. Yeah, Beam has been all right, but Twitch has some pretty cool features. It would actually be kind of nice to have a Twitch simulcast, then we could save And we could save clips, and there's more community features on there than YouTube. Toby service model? That seems useful too. What was that like? Oh yeah, this. Oh, you think maybe it's sending this over endpoint 5? Kind of doubt it, but this doesn't look like the same shape. But maybe it's converting this to some other format. I think it could be some compressed version of one of these. Oh, where was my XVI? I wonder if it's part of this. This looks lightly compressed. Like, I don't know, it's kind of hard to tell by eye, but it looks a little bit repetitious, but not like uncompressed numbers or code. I'm curious what that looks like in BinViz, my old friend. Sigh. No. Copy. Oh. Does that look like a banding kind of repeating pattern? Or is that just a scaling artifact? That might be a scaling artifact. Yeah, that's just moire. Oh, that's a good suggestion from Jonah, that it would be useful to have more just like small stream or small videos or other resources that are easier to consume with just information about reverse engineering. I mean, just for reference, like my goal is not just to produce like super long YouTube videos. These are just streams of stuff that like I have to do anyway, and my goal is to edit them together. But specifically doing edited videos that are about kind of individual reversing techniques, like I could see that being useful. Like, I guess, I don't know, I feel like nothing I do is special. I just kind of poke at stuff until I get the information I want. But if there's something specifically that I could go through, then that might be a thing that I could do for sure. Yeah, let's see if any of the data we have matches this file at all. So tracker model and oh, I'm going to so many sneezes today. I feel like I keep stifling them. Okay, here's the stuff we saw on endpoint 5. Oh no, that's another copy of the tracker model. Where is our endpoint 5 data? Okay, 1.5. So there's a bunch of commands up here that we can probably just figure out directly, but then there's this chunk of binary vomit down here that I'm curious about. Let's just pick something kind of in the middle of here and see if it happens to show up in this file. I thought I did just a big giant grep of the whole directory though, and it didn't come up with anything. Oops. So the find works. Yeah, I don't think we're that lucky. I wouldn't be surprised if they did some kind of, like, obfuscation transform on this data, whatever it is. Like, clearly this is something the software has to be able to generate, but it might not necessarily just be stored verbatim on disk. I'm also just deciding where to go with this video. Like, would it be, is there a particular endpoint? Like, it'd be really nice to get this working on a Raspberry Pi, but if that's going to take way too much effort to fit into a reasonable amount of video, then maybe there's some other stopping point. Like, maybe just this investigation is interesting to people. It'd be really nice to get this to do something new, but I also don't necessarily want to only make super long videos, you know? Oh, that's a neat idea that Ratmir suggests, that I could work on a CrackMe or a CTF to show off techniques. Perhaps. I feel like I'm not, like, I don't know, I'm not like an expert reverse engineer, especially not at PC stuff. So maybe there are other people who do a better job at that, but I guess not everyone is taking the time to explain what they do on YouTube, so there's that. I wonder if this is just a pile of floating point numbers. You see how most of these numbers start with like a B something or other, like BE, BF, BC. I wonder if that's an exponent. My guess is these are numbers, maybe compressed numbers, but mostly numbers. I mean, obviously these are all numbers, but I think those are numbers indicating model parameters probably. Whereas these, I still don't know if these are instructions or parameters. This is one of those times when it would be really nice to have just a system-wide debugger that you could throw at this problem. I don't know, honestly something that could show me the inter-process communication between a group of processes right now would be super useful. Maybe even just something that lets me, I don't know, that named pipe. I wonder who else talks to it. Go to the pipe server. Oh, maybe we'll actually look at where this pipe goes. 3DO, is that going on the stack? Yeah, ESP plus 8. G6 in it. Is this an offset to a default pipe name, maybe? It's probably an error code. I think the pipe name is coming in as the first argument here, although I haven't been tracing this super closely. Oh, maybe that was a prefix. Okay, maybe that's just the pipe name pattern, and that was just printfing whatever it wants in there. So that just disappears somewhere else. Where do we actually end up opening the named pipe? Now I've got to remember how this works in Windows. Would that be, oh, create named pipe. I thought it was going to be create file, but who uses this? Pipe server thread. Connect named pipe. Some of this would be easier to go through and trace actually just by running it. What does the signature for this actually look like? Wow. Speaking of not making enormous videos, it might be good to wrap this up soon, and I can spend some time editing and doing other stuff, and then we can come back to this later. I'm kind of torn at this point between going deeper into this and trying to wrap up what I've got. And as far as going deeper in, I think, well, the two things that seem worth pursuing to me are, trying to debug this Windows software some to just see what order things start up in and where those EP5 messages are actually coming from. Maybe try to debug multiple of the processes that are running and try to step them through the initialization process. The other thing that's almost totally orthogonal to that is just don't even worry about where this binary blob comes from. Just capture it from this and send it to the device, and then try to write a standalone program that interprets the results, which also could be pretty complicated, but might enlighten us as to what other steps are necessary. Could also just talk with Bill from AT Makers and see which of these seem useful for him and the use cases he knows about. Microhex is wondering if there's a graphical front end for GDB disassembling. I'm not quite sure what you mean. There's like a visual mode. There's like text UI mode for GDB. There's like the data display debugger DDD, but that's less about disassembly and more about data structures. Oh, and then Sodium is asking if maybe the Process Explorer system internal stuff let us poke around in named pipes. Yeah, I forget what those do. Do I have those installed on here? I might already. Maybe I don't. I don't think I already have them installed. Well, there's a pipe list, which is better than nothing. Can I download the whole pack? You can do it, little graph. Why is it taking so long? That was pipe list 64 versus 32. Well, there's the Toby pipes sitting there right there staring at us. Several of them, in fact. So we have a connector pipe, several client connections, streaming engine. Oh, that's something different probably. Toby, client Toby. So, I mean, this looks like the one that we just saw because it has a dash instead of an underscore. Is that right? Toby dash. So that narrows it down, actually. We know it's this pipe. And this is the model number. I'm assuming this is just the model number and serial number of the sensor we're using. So then there's a client pipe that's based off of that same name. Another client pipe down here. I guess we could check to see if anybody else is generating that name, or if this is the only place that we actually, like just by searching for Toby Dash. Well, potentially several places, but we can narrow this down. What about Toby Dash %s? That's just the Windale L. So firmware upgrade. We could just take a look at how this communicates, that Toby firmware upgrade. I don't know if that's relevant still, but it could be a good example. Where is that? IX. Anyway, we want strings. Oh, we want uppercase. Oh. That looks relevant. Stream engine source, transport, pipe, windows. Okay. So this has the Toby dash prefix, and it has this client underscore whatever prefix. This might not necessarily know how to create that name. But this is interesting. Where would this be used? Oh, maybe it's just taking the same string that appears in the URL and turning it into a pipe name. Maybe this is the client. Got some good file names here. Transport pipe windows. Toby session protocol, maybe? I assume this is how it generates through turn socket. Like this is maybe some local number of, I guess it's the time probably. And then this is the server's socket number, which should match this. So this is the server. This is the code that we're seeing right now, generating the client. Okay, well, I think that answers that question. So this is just going to be presumably statically linked into all the programs that need it. Like this might even just be a header file or something they have. Connect named pipe. Oh, that's the function name. Transport pipe T connect. I wonder if we can find any good neighbor functions. What is this? It's probably closing. I'm just looking nearby to see if I see something that's obviously like a write or a read. Transport pipe send. Receive. Let's see who calls send. Now it might actually start to become interesting to see how those USB endpoint 5 related messages were actually structured in the pipe, because then we would know whether we're seeing that. Just a vtable? So this is the constructor for that transport pipe. We can't just directly look for calls to its methods because they appear to be virtual. Ooh, there's this whole thing. Maybe you can remote this across the network. Toby TTP. I guess they were really serious about having a URL for the eye tracker. I guess TET is... I don't know what this means yet, but I've been seeing TET all over, and some of the algorithms for IX seem to be implemented in this component called TET server. This is transport create. We could, I mean, we know the vtable offset. We could just look for calls based on that vtable offset. 0, 4, 8, C, 10. Did I not say find all occurrences? Okay, would not be base pointer related. It would not be DB. It would not be an add. Be one of these. Most of those are byte offsets. It also might be, it doesn't look exactly like this. Yeah, none of those. Interesting. Oh, there's a... That's right, x86 can do this. What a weird instruction. Let's look for those. Yeah, we've got calls. Oh, and here's one inside. What is that? TOEI firmware upgrade. Upgrade firmware. Is it an export? That is an export. Get package metadata, iTracker metadata, state, upgrade firmware. So this might be a transport send. That's not super informative. Handling errors, like translating errors maybe. Upgrader TXNG. Transactioning. Oh, where was that call that we were just in? Transport send wrap. Right there. I keep trying to decode this as like x86-64 calling convention. Like, no, no. This stuff just goes on the stack. Really? Ah, this is like an upgrade context vtable maybe. So, I mean, just looking at this statically, this transport send wrap is not amazingly useful, but potentially one thing we could do is actually just attach a debugger and use that to watch these packets go through. I don't think I quite want to do that on this stream, because this stream's already gotten pretty long. All right, who else calls this wrapper? Oh, just this function. Okay. So I guess in that case, this function would just be, I'm just going to call it send firmware. It would be really nice if I could tell if this matched the binary blobs that we've been seeing. You could also just start to look for the equivalent of this in other binaries. Actually, who would be, like, and this still comes back to the fact that I don't even know if what I'm looking for is the firmware upgrade or not. If I could just have any tool, something that just snoops on all the IPC traffic between programs would be super handy. It might be useful to know which programs have a pipe client. So maybe there's some strings we could grep for that will tell us that. Like transport pipe. Ah, that's kind of manageable. Is that SES Windows maybe? Okay, so maybe I was wrong about the pipe client just being statically linked into everything. Maybe it's just statically linked into a couple of programs. And maybe that SES Windows thing in the service? Huh, let's see what's in there. So we're going to see a pipe server in here too. And kernel 32 in WinSock. Exports, run service, stop service. So this is a service. That busts my theory about this being a client library DLL. Is this a service that we've seen? Wow, this has actually got a variety of stuff in it. There's like OpenCV stuff in it, and gaze, point, producer, create. A lot of symbols. There's more here than I was expecting. Let's look at strings first. Is this statically linked to OpenCV? ULC? I wonder if this is something they bought from another company, or just like an old version of something. Is this something base64'd? Model path? I'd be kind of surprised. Oh, so this is the model we saw earlier. So the model slash 3D.point space.xml. Maybe SES is something like Stream Engine server. Maybe this talks to the service and then everything else talks to it, and there isn't like a client library proper. This would be a good, like, this is where I would expect to see that binary blob come from, in fact, if I'm understanding this thing's architectural position correctly. Let's maybe try to find that transport we were just looking at. Pipe connect. Oh, we've got symbols for this one. Ha ha ha. Oh, that's amazing. Transport pipe connect with symbols. Great. Here's the whole vtable. There's the constructor. Man, I liked my names better. Theirs probably fit better with the C++ ABI they're using, though. So, transport pipe. This is inside transport create. This is where we just were, except it's a bizarre universe where everything has symbols. Oh yeah, the good old foof bug. Yeah, F00, FC7, C8 was one of my favorites too. for a very small portion of time, that would just hard lock the processor. It was a really weird bug. I remember it being something, I don't know, some like weird bus state deadlock that it would get it into, like it's some kind of invalid prefix that confuses the processor's fetch loop, or its fetch logic. What is this character? Slash. Oh, a tracker, TTP, ensure time sync connected, or just plain old connect. Initialize. Tracker TTP? Because the funny thing is, if they're making a joke based on HTTP, that was like hypertext transport protocol, so is it the tracker text transport protocol? Anyway, here's the tracker vtable. Ooh, look at all that. Diagnostics image. I guess that's how you get just like a camera image out of the trackers with software tracking, at least. I wonder if you can get frames out of the trackers, like this one with the EyeChip. Calibration points. Compute and apply. Is this done locally? Operation queue, send and receive response. Okay, that's done elsewhere. So, of all the places that we get calls here, is anything going to be USB related that we might want to look at? Get configured. Oh, these symbols are great. Persistent files. Is this meant to have a remote file system that you can access on the server or on the hardware itself? That's very strange. I assume that's something that the service manages, not the hardware. Enumerate illumination modes. I think we're probably a few levels of abstraction too high to see information about those N.5 packets. But this is still interesting to know what's on the other side. Tracker TTP. Internal log. Process until response. Oh, send custom command in tracker custom T. Huh. thought this transport send was at least in a vtable somewhere, but now I'm seeing no references. How does this work? This is at a different level of abstraction, this tracker TTP send and receive response, but I think something in between that and where we just were is maybe what I want. Oh, that's the send right there. That call EAX plus 10. Let's just look for more of those. These look fun. Send and receive response, which is where we just were. Separable filter 2D. That's probably different. Box filter. Transport send, tracker get properties. And this one we didn't have any callers for, so I doubt this is useful. So is the only send we have in send and retrieve response right here? Maybe it is. Yeah, I mean, I guess thinking about the other end of this, the other end seemed to be responding a lot, so maybe this is the right place. So I think everything else is going to be in this tracker TTP class, which I still think is maybe too high an abstraction layer for looking for that endpoint 5 stuff. Digital sync port, what that is. Sync for multiple trackers, maybe. Lens configuration. Is it possible the binary blob is some kind of compressed blob of data about the lens? If so, why would they not include that with the firmware? Is that a size? That's 3 million. Maybe that's a timeout or a maximum size. Well, I think it might be about time to wrap this up. I'm kind of losing my direction here. And while there's a lot of interesting stuff to take apart, I think it might be worth taking a step back and thinking about what to do next. It does seem like actually just trying to recreate this on a Raspberry by sending the binary blob might be the next step. I'm just going to take one more look at these blobs that we have. So this is the endpoint 5 out blob. And then here's the endpoint 3 in. So this is all the stuff we're receiving from the device. And, well, both of these are with the exception of control packets. So endpoint 0 stuff isn't in either of these. But with that out of the way, this is all the stuff we're getting in. This is all the stuff we're sending out. I just noticed these strings. False, gaze data, image, strobe. I wasn't really expecting this device to be especially self-describing, but maybe this is receiving all the... Huh. I wonder if this is a self-describing protocol. It's got stuff like right eyeball center position, right eye detected. I wonder if these are going to correspond with fields that we see later on. Test string. These appear to have numeric codes before them. There's a length and then a tag of some sort. I wonder if it's looking up the tags that are going to be used later on in the protocol. Hello, NIR. Hello, NIR. Well, if these do correspond with the data we're getting back, then this is definitely high level enough to start building applications on top of without having to do any, any algorithmic stuff that might be infringing on their territory. So this is the content we were getting back. Let's say that's a value, like maybe that's a 32-bit result. Maybe one of these is like a tag that describes it, and it could correspond with that table we saw up there. So that's potentially easier to take apart than it could be. And then as far as the data that we're sending out, a bunch of these commands, which I think these are going to be requests that ask for these, probably. It's probably like, hey, tell me about item F or 5D2 or whatever, and then it returns. And then here's how that blob starts. I think that's the beginning of the blob. Maybe some sizes or versions before it. I mean, if I just get this working by copying the blob, then there might be opportunities to try, well, what if you change the blob? Does it break the calibration? Does the device crash? What if you send the command that turns it on without sending the blob at all? It doesn't seem like it would be the entire firmware, since it didn't look like the device was resetting after it got this. And if it was going to get the entire firmware over USB, I would think they wouldn't have bothered with the flash memory chip. Yeah. Well, I think I'm going to get back to video editing, get some other stuff released, and we can think about where to go with this project, what the options are going to be as far as videos and endpoints for the project, and ways to make this interesting for everyone. Just checking to see if I, oh, tet equals Toby eye tracker, quite possibly. Interesting. Okay, and then Nick also mentioned Procmon will let me trace the pipe calls. Yeah, so one thing to do is, I don't know, like I still don't know what binary is responsible for the behavior we care about. If it is this SES thing, we could run that under Procmon. But I think it's a good stopping point, and we can figure out what to do with this later. I think I got the microscope footage I came for too, which is nice. Can try not to delete it this time. Well, corrupt it. I don't think we need that. Sure are a lot of layers to this software. Like, they have a lot of software engineers that they need doing stuff. Oh, interesting. Sodium says Procmon snoops in the whole system, so is there a way I could use that to just get the pipe calls from everything? That would be nice. I've used that for registry stuff, I just haven't used it for pipe things. But I think we can save that for next time. I'm tired of working on this, and I've been streaming for 5.5 hours. At least it seems like the rig works again. Thanks for stopping by, everyone. As usual, big thanks to my patrons for keeping the lights on in here. And I'll be back to editing stuff so that we can get some more stuff released on the blog so that that seems like less of a ghost town. But if you haven't seen it, I hope you check out the latest edited video, which I put together from the little vacuum fluorescent display project we did a little while ago on the stream. All right, catch you later.